n factorial is the product of first n natural numbers. 0 is not a natural number, even then 1 works as the value of 0 factorial. So is there any value which can work for minus 1 factorial? Or is there any value which can work for minus 1 factorial or minus 2 factorial? Do minus 5c3, 7c8, minus 7p8 etc. also represents some real numbers? And to do 1 over minus 1 factorial behaves in the same way as minus 1 factorial? If you are curious to know these questions, then get ready to enjoy the video.
You are watching this video means you know about factorials. Let's have a quick review. So n factorial is represented like this or like this. N factorial is the product of first n natural numbers, means n times n minus 1 times n minus 2 and so on up to 1, right? Okay, now as per our definition, if we see, then this part written after n is also product of some natural numbers, more precisely product of first n minus 1 natural numbers, means we can write this part as n minus 1 factorial. Okay, for example, 6 factorial can be written as 6 times 6 minus 1 means 5 factorial, and value of 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is equal to 120. Now what about 0 factorial? What is the value of 0 factorial? We just write an equation n factorial equals to n times n minus 1 factorial. If in this equation we put n equals to 1, then we get 1 factorial equals to 1 times 0 factorial, and 1 factorial is equal to 1, so we get 0 factorial equals to 1. So this explanation of 0 factorial equals to 1 is not correct. Why? Because this part is written only for first n natural numbers, means n minus 1 factorial is equal to n minus 1 times n minus 2 and so on up to n minus 1, right? So this formula must not be valid for n equal to 1 because there is no natural number before 1. But even then, this result that 0 factorial is equal to 1 is correct because it is working in different applications of factorial. Okay, we will come to this later on the correct explanation of 0 factorial in some another video. What is NCR? Let's proceed. So NCR is equal to n factorial over r factorial times n minus r factorial. Okay. Now for example, suppose we have to find 5c3, so it is equal to 5 factorial over 3 factorial times 5 minus 3 factorial, means 5 times 4 times 3 factorial over 3 factorial times 2 factorial, which on solving gives us 10. Let's write some more. Suppose 5c2, 7c3, 10c4 etc. Here in one more thing what we can do is that here in the subscript 2 is written, so we can write two natural numbers from 5 times 4 and two natural numbers in the denominator. Similarly here in subscript 3 is written, so in the numerator we can write only 3 natural numbers, 7 times 6 times 5, and in the denominator 3 times 2 times 1. Here in 10c4, 4 is written in the subscript, so 10 times 9 times 8 times 7 upon 4 times 3 times 2 times 1. Okay. Now what about minus 1 factorial and minus 2 factorial? As we have found the value of 0 factorial equal to 1, can we find a value of minus 1 factorial or minus 5c2? Let us try. Suppose n factorial equals to n times n minus 1 factorial. Let us try to put n equal to 0. What we get? We get 0 factorial equals to 0 times 0 minus 1 factorial, means 1 over 0 is equal to minus 1 factorial, and this is undefined. right? Why? Because 1 over 0 is undefined. But can we write 1 over minus 1 factorial equals to 0? Is it so? Yeah, maybe, maybe not. We will see it in the video. And minus 5c2 can be written as minus 5 factorial over 2 factorial times minus 5 minus 2 factorial, which is equals to minus 5 times minus 6 times minus 7 factorial. We have to decrease the numbers over 2 factorials times minus 7 factorials, and this get cancelled out here, and finally we have 15. Is it valid or not? Is it valid or not? How can we see this? Let's try to implement these informations in some applications of 5c2 or minus 5c2 like this. So one of the applications of this combination C is binomial theorem. What is the binomial theorem? Any binomial x plus y, if it is raised to the power of any natural number n, then its algebraic expansion can be written like nc0 x raised to the power n plus nc1 x raised to the power n minus 1 times y plus nc2 times x raised to the power n minus 2 y square, and so on up to ncn times y raised to the power n. So if we have to write the expansion of 1 plus x raised to the power n, we can write nc0 plus nc1 times x plus nc2 times x square, and so on up to ncn times x raised to the power n. For example, 1 plus x cube, 1 plus x whole cube, it can be written as 3c0 plus 3c1 times x plus 3c2 times x square plus 3c3 times x cube, which is equal to 1 plus 3x plus 3x square plus x cube. But if we try to write 1 plus x raised to the power minus 3, can we implement binomial theorem in it? Okay, so we will try to implement binomial theorem in it, and we will cross check our result by finding this expansion in some another way. So what we will do, we will find the expansion of 1 minus x raised to the power minus 3 in two ways. One, without using binomial theorem, and second, using binomial theorem. So let's start without using binomial theorem. So let's start with the series 1 plus x square plus x cube, and so on up to infinite terms. Here we will take mod of x less than 1 so that the series remain convergent. So s times x can be written as x plus x square plus x cube, and so on to infinite, right? Here we have multiplied each term by x, so multiplying 1 with x we get x square, x cube, and so on. Now if we subtract this series written below from the series written above, we get s minus s times x equals to 1, because all the terms get cancelled out except 1, right? So we get s equals to 1 over 1 minus x. We can take s as common. So s times 1 minus x equals to 1, and we get s equals to 1 over 1 minus x. Means what we have found? We have found that 1 over 1 minus x is equal to 1 plus x square plus x cube, and so on, right? Great. Now in this series, if we differentiate it with respect to x, we have to differentiate it with respect to f. If you want to do anything else to find 1 minus x raised to the power minus 3, you can implement that. Here I am differentiating it. So on differentiating on the left hand side, we get 1 over 1 minus x whole square, and on the right hand side what we get, let us first write 1 over 1 minus x, that is 1 plus x square plus x cube, and so on. On differentiating, we get 1 over 1 minus x square is equal to 0 plus 1 plus 2x plus 3x square plus 4x cube, and so on, right? Again differentiate it with respect to x. So on the left hand side we will get 2 over 1 minus x whole cube equals to 2 plus 3 times 2x plus 4 times 3 x square and so on, right? Okay, now 1 over 1 minus x whole cube can be written as 2 times 1 over 2 plus 3 times 2 over 2 plus 4 times 3 over 2 x square, here it was x and so on. Great. So here we have found the expansion of 1 minus x raised to the power minus 3 without using binomial theorem. If you want to find it in some other way, you can do that. If you want to use only these first few terms of 1 over 1 minus x, then also you can find some parts of the series and later on you can check. Okay, so now we will try to do it with using binomial theorem. So let's try to apply 1 minus x raised to the power minus 3, right? We can write it as minus 3c0, great, minus 3c1 times x plus minus 3c2 times x square minus 3c3 times x cube plus and so on. We are using this alternate sign minus plus minus plus. Why? Because in the binomial we have this minus before x, that's why. Or you can also write this minus with x, so x square will automatically become positive. Okay, minus 3 factorial over 0 factorial times minus 3 factorial minus 3 factorial over 1 factorial times minus 3 minus 1 factorial means minus 4 factorial times x plus minus 3 factorial over 2 factorial times minus 3 minus 2 means minus 5 factorial x cube x square minus 3 factorial over 3 factorial times minus 6 factorial x cube and so on. Here minus 3 factorial gets cancelled out, so we get 1. Here minus 3 times minus 4 factorial can be written, and in the denominator it is 1 factorial times minus 4 factorial, great, plus here it's x also, plus minus 3 times minus 4 times minus 5 factorial over 2 factorial times minus 5 factorial times x square minus 3 times minus 4 times minus 5 times minus 6 factorial times x cube over 3 factorial times minus 6 factorial. Now this minus 6 factorial gets cancelled out. Here minus 5 factorial get cancelled out, minus 4 factorial cancelled out. What we get? We get 1 plus 3x plus 3 into 4 over 2x square, and here also minus minus plus, minus with minus plus, and 3 first let's write here we get 4 times 5 over 2 x cube and so on, right? So in the first two terms, if we multiply and divide by 2, then we will notice that all the terms which we are getting are same. We obtain the same series, means this minus NCR is working. It is working in the same way. Maybe writing this is incorrect, maybe applying this is incorrect, but after all it is working. It's giving us the same result, right? So let's generalize. Suppose we have 1 plus x raised to the power n or 1 minus x raised to the power n, so we can do it normally using binomial theorem. Okay, now if we have 1 minus x raised to the power n minus n, so what will happen? We will get minus nc0 plus minus nc1 times x plus minus nc2 times x square and so on, minus nc 3 times x cube. Okay, now we have a method that in the subscript it is 1 written here, so let's write only one number in the numerator and 1 in the denominator. In this third term subscript is 2, so let's take two numbers in the numerator, minus n and minus n minus 1, and 2 in the denominator, 2 times 1, nice, over x square, and similarly minus n minus 1 minus n minus 2, 3 in the numerator and 3 in the denominator times x cube and so on. So now you can notice that here it is 1 minus and here minus, we get plus, right? Here also two negative numbers are there, so negative times negative get positive. Here 4 times minus sign is used, so we will get positive. So n over 1 can be written as nc1 plus, here this term can be written as n plus 1 c2. This third one can be written as n plus 2 c3 and x cube and so on, right? So you can learn this as it is. If inside the bracket and in the power both the signs are minus, then all the terms which we will get is positive, will be positive. And similarly, if we try to write the expansion of 1 plus x raised to the power minus 1, then we will get 1 minus nc1 times x plus n plus 1c2 times x square plus n plus 2c3 times x cube and so on. So in the binomial theorem, only subscript was increasing, but here the superscript is also increasing. So this is the difference. Similarly, if you try to find something like npr, like something np minus 7p2, let's try to find it. So what can we write? We can write it minus 7 factorial over minus 7 minus 2 factorial, right? Okay, so we can write it as minus 7 times minus 8 times minus 9 factorial, and in the denominator we get minus 9 factorial, and we just cancel it out. So we get 7 times 8 means 56, and this is also the incorrect way to reach here, but I'm sure it will also be working. So if you have any application to show that it is working, so tell us in comments. And if you find the content interesting, then please don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.